We're continuing on with 3.4, the ambiguous case, but we're looking at real examples where we would use this. So this says how many triangles does PQR can be drawn with an angle P 51, Q 12, and side P 10. We put our angle P here. We Side P is going to be directly across from it. This is side P, and Q is going to be adjacent. It doesn't matter if we would have done it over here or over there. We still would have angle side side. Okay, it doesn't really matter how we would have drawn this. We're going to look at renumbering this, so then we can use the cases that we showed before. So we call the angle that we're given side A, and then that makes this length A. We give the other side that we are given is called B. So that means that this is this is 12. This is also B, so we're going to call this B and that B. And that just lets us use what we know, and that means that this is C. We'll leave that R there. So let's look at these cases here. We want to compare length A to B sine A and to B. So we want B sine A. Well, in this case, we said B was 12. We're doing B sine A. Sine A was 51. Well, 12 sine 51, if we put in our calculator, is equal to 9.33. So what we want to do is we want to compare side length A to that. Well, A is 10. So how does 10 compare to 9.3? 10 is greater than. In other words, we have A is greater than B sine A. So let's look back here. And are we dealing with an acute? 51 is acute. So we have acute, and we have A is greater than B sine A. So we have this case. One triangle is A is greater than B sine A. Oh, look, but we have A is greater than B sine A. We can either be this case or this case. So we have to look at side length A and B. How do those relate to one another? Well, A is 10. B, in this case, side length B is 12. So how does this work? A and B, 10 and 12. What are we looking for here? We're saying, is A less than B? Is 10 less than 12? Or is 10 greater than or equal to 12? Looks like we're looking at this case, so we can say that there are two triangles possible. Next up, it says if P equals 45, Q equals 24, and P equals 12, again, we're saying how many triangles are possible. So let's rename this. Let's call this A. Then this is side length here. Side length right across from it is 12, is A. This we're going to call side length B. So we always want to look at B sine A. So we have 24 sine 45 is equal to 16.97. We're always comparing this. We're always comparing B sine A to A. So we want to see what relationship. If it's A is less than, there's no triangles. If it's equal to or greater than, then we have some other cases. We said A was 12. So how does 12 compare to 16.97? Well, that's less than. Because we said A is less than B sine A is less than B sine A, we are looking at no triangle. In other words, this side is not long enough to ever hit. No triangle. So there will be times when I ask you a question, I ask you to solve a triangle, and your answer is, this triangle does not exist. Next up, if P equals 112, Q equals 12, and side length P is 13. So I'm dealing, right away, I see that I'm dealing with an obtuse. So there's only two possibilities here. Let's rename this as A. So side length A is going to be 13. I'm putting 13 over here, that's A. And B is 12. So I'm always looking at B sine A. So B in this case, actually I'm not looking at B sine A at all. Let's look at obtuse. I am looking just the relationship between A and B. No triangle if A is less than, one triangle if A is greater than B. So A is 13, B is 12. Oops. Yes, I did that right. Since 13 is greater than 12, therefore one triangle possible. So hopefully you have in front of you, you've already printed the notes and you keep looking back to this sheet because this sheet is your Bible. This tells you one triangle, two triangle, all of that stuff. Okay. Next up, if P is 125, Q is 8.44, and P is equal to 6.53. So it's, again, obtuse. Let's call this A. This is B. And we have side A here is 6.53. In obtuse, all we're doing is comparing A and B. Well, in this case, A we said was 6.53, B is 8.44. Since we have less than, since A is less than B, or equal to B, we have no triangles. No triangle. There's no way that that 6.53 is ever going to hit if this is 8, this side is 8.4. Okay? Last thing I just wanted to add, if you ever do get something like this, where there's two triangles, you're going to have to draw out two separate triangles, and you're going to have to use the fact that the sine of 40 is equal to the sine of 140. Okay? In other words, the sine of 60 is equal to the sine of 120. What am I doing? Complements or supplements adding up to 180 have the same sign. So you're going to first of all look at the triangle that has a acute angle. You're going to solve for that angle using the sine law. Then you're going to draw that second possible triangle and use the sine law, but instead of, if you get your angle to be 40, now use 140 there instead and solve that triangle. And I can show you as we come to an example in class tomorrow. Actually, that's probably what I'll start with, is an example like that tomorrow. Okay?